Hi everyone, how's it going? Welcome back to the geography class. I am your host today again, teacher Harit Chayasak. And in this week, we are going to talk about the Earth's physical change. As we mentioned earlier last week about the technological advancement and the geographical instruments that we use to study and creating the geographical informations. Today, we're gonna study those information to understand more about our Earth, how's it change and how's it affect to the human being. So before we begin, I want to explain just a little bit about why should we study about these aspects, since it's also kind of like related to science studies. So social studies, we try to studies about human and its environment. There are so many aspects, they are so broad. So in order to understand humans, we must understand their environments, the components that involve in human development, which means these kind of studies are also overlap with the studies in many subjects, especially in science studies. So when we study about the Earth physical change or the Earth structure and stuff, we're not going to focus too deep into these kind of topics, just the general. What I want to see from you is how well you understand these relation, the cause from nature that develop into humans today and in the past. That is what I want you to focus on, and I want to see it from you. Okay, then let's moving on. Okay, so to understand about the Earth, let's talk about the Earth and its crust. So Earth is a planet in the solar system, and I believe every one of you are already known. So it orbits around the sun, which in the times of a year creating seasons, and also it rotates around its own axis. It's about 24 hours, so that is including one day. So the Earth turns around itself in one rotation, it's equal one day. So its diameter is lengthened from the north to the south pole at 12,714 kilometers. And in the around equators, it lengths around 12,757 kilometers. So Earth is in sphere shape and consists of humidity and gas, water on the surface, land and surface, as well as living organism. So we have waters as a elements of the earth. We have living things, we have land that we're standing on, and we also have gas such as air, nitrogen, everything that we breathe in, humidity to create rains, so on and so forth. So these elements on earth has categorized into four related spheres. So the word we call sphere, not a circle, because circles represent only two dimensions, but sphere includes three dimensions, which mean they are length, they are width, and they are depth. Okay, so the sphere that we talk about, there are four important spheres. There are lithosphere, there are atmosphere, there are hydrosphere and biosphere. Also, in some textbook or some class, they also include another sphere, which is the cryosphere, which is talk about the formation of ice. But today in this class, we are going to focus only these four spheres first. So let's begin with lithosphere. So lithosphere, the lithosphere, sometimes we can call them geosphere. It refers to all the rocks of the earth, which include the planet's crust and the uppermost mantle. So let's take a look at the Earth's structure. Earth's structure can be divided into two ways. So number one, we divide it by the chemical components, which it puts in three layers. Layers number one are the crust or the plate. Layers number two are mantle, and the layers number three are the core of the earth. So second ways to categorize is divided by mechanical properties, which leaving us 5 layers. So the layers number 1 is the lithosphere. Its depth and thickness around from the 0 to 100 kilometers, which include continental crust, ocean crust, uppermost mantle. Second layers is asthenosphere, which depths around 100 to 700 kilometers, which are the upper mantle, and in these layers of mantle, it's in the form of magma. Next is mesosphere, which is depth from 700 to 2,900 kilometers. This is the lower mantle part. So the next is the outer core, depth from 2,900 to 5,150 kilometers. And the last layer, the depths of the Earth, is the inner core, which is length around 5,150 to 6,371 kilometers. So as you can see from the diagrams, the layers are from the outermost to the innermost. Starting again, if we divide it in on the left side, this is divided in in mechanical properties, and on the right side it's divided by the chemical components, which leave only the crust, the mantle, and the core. Okay, let's moving on. So the Earth crust is including continental crust, which is the land, and the oceanic crust, or the ocean floor. So even though you can't see the land under the water, but there is still a land. So the Earth is basically a giant continent put in together like a jigsaw, but many part of the continent can't be seen because it was underwater. So it leaves us, if we look to the Earth from the outer space, you're going to see only the main continents that we're living in, which is the Eurasia, or Europe and Asia continent. We have Africa, North and South America. We have Australia and Oceania. So these are the continents that you can see it above water. You can see it from space, only this main continent. But underneath it, under the water, these continents also expand. And I will show you how each continent expands underwater just a little bit. So the Earth crust is averaged at 35 kilometers depth, thick, and is settled on top of the mantle. The way to differentiate the mantle and Earth crust layer, we use so-called the Mohorovičić discontinuity. So Mohorovičić is named after the scientist who discovered the different layers of the Earth by detecting the increase in the speed of the waves that go through underneath the Earth. So the deeper it goes, the harder and the more compact and in molecules in the layer, in the elements underneath the Earth, the faster these waves are able to travel. So that's how he discovered that when it changes speed, it means it changing in the layers and element components underneath the ground. Okay, so the Earth crust is the part of lithosphere. Now talk about the Earth's mantle. Earth's mantle is settled below Earth crust at around 100 to 2,900 kilometers depth. Again, don't be confused. In the Earth's mantle, they can be divided into 3 layers. So number 1 is the uppermost mantle, which is depth around 30 to 100 kilometers. So the uppermost mantle are the part of lithosphere. And then come to the middle of the mantle layer, we call the upper mantle, which is depth from 100 to 700 kilometers. And again, like I said earlier, in this part of the Earth's layer are what's so-called magma elements, which is part of the asthenosphere. So the word lithosphere means ธรณีภาค in Thai, and the word asthenosphere means ฐาน ธรณีภาค in Thai. Okay, so the last part of the mantle is the lower mantle, which is the biggest part of the mantle's layer, which is depth around 700 to 2,900 kilometers. In some sources, so don't be confused, depends on how you measure. In some sources, they will list the depth is around 2,880 kilometers. And the temperature at the bottom, the deepest of the mantle layers are around 2,800 degrees Celsius. So if you're planning to go down there very soon, please bring lots of ice. I'm just kidding. Let's moving on. Earth's core. Now we go to the deepest part of the Earth. However, we can also divide these layers into two layers, the inner core and the outer core. So the inner core, however, is assumed to be a solid layer of nickel, mostly composed of nickel and iron, at a very high pressure and temperature. So with this compress of pressure and temperature resulting in its forming as a solid state. It is the deepest part of the Earth, of course, which is the inner. This little thing, if you take a look here in the picture on the right, so this is the inner core. So it is at depth and thick around 1,255 kilometers thick. So it's still very thick, even though it's the innerst part of the Earth. And then comes to the outer core, which also assumed to be a liquid layers of nickel and iron at very high pressure. So this is the outer core. Also has a very high temperature around 2,800 to 3,100 degrees Celsius. So the outer core is moving in conjunction with Earth's rotation. So like again, the inner core, this one is solid part and the outer one is liquid part, and this liquid part moving along Earth's rotation. And these theories suggest how the Earth are able to create the electromagnetic field and gravity. Okay, let's moving on. Lithosphere changing process. So lithosphere is Earth crust and uppermost mantle layer. Lithosphere is continually changing, which its process came from two processes. So this changing process, you can also call them the tectonic process. So the process can be formed in two ways, the endogenic process and the exogenic process. Endogenic process. So heat and pressure from magma deep into the Earth cause the lithosphere to continually moving and changing. So our lands that we are stepping on, this continent, the place we are living on, is basically moving all the time. So this changing process, or we call the tectonic process, can be formed by two ways in terms of the volcanism process and diastrophism process. And then another one is the lithosphere mobility or motion or movement has three different types of motion. They are divergent plates motion, they are convergent plates motion, and they are transform plates motion. So let's talk about the tectonic process first. Number one, the volcanism process. Volcanism process กระบวนการ ของภูเขาไฟ so volcanism process is a fast tectonic process that caused by energy under the earth crust pushing out magma into lava due to high pressure and extremely high heat. So the heat generates pressure, and this pressure underneath the earth is trying to push out these magma in the upper mantle layer. And also the earth, since it's not the one conceal layers, it still have cracks, it still have holes and ways that these magma can escape from underneath the earth. So types of volcanoes, as you can see here, there are different types of volcano. There are fissure volcano. These types of volcano are gentle basaltic slope of lava, which means when lavas come out, it does not go very high, and it can release lots of lava into wide area. So the lava that came out, lava also, the magma, when it's released out, we call them lava. Okay, so these lava, when it's cooled down, it becomes the new terrain. So as you can see here, this is the tectonic process that it changed the layers and terrains of the earth crust, also increased the scale and area. So when the volcanic eruptions happens, lavas come out. When it's cooled out, it forms into elements such as rock and stone, increasing the areas of surface or create new terrain. So these types of volcanoes also tells you how much the lavas or the magma underneath will come out and will resulting in changing in those areas. So like again, the fissure volcano spread the lava very wide. Shield volcano, of course, its slope not too greater though, a little more slope than the fissure volcano, but still not that high and change in elevation. So it will shape of the, if you remember the shield the warrior used in the movies, so in that kind of slope, gentle slope, and on the top is where the lava came out at the vent. So also it have the gentle slope of basaltic lava flows. Next is the dome volcano. So this dome volcano, on the top of the vent, the slope is thicker and have higher elevation. However, it's not as sharp as the ash cinder volcano and the composite volcano. And the other one is caldera volcano. In this caldera volcano is basically a giant vent that sometimes you can't see, because in these vents the water were going in and form it become a small lake or swamp, but the vents of the volcano is underneath. So when it's eruption, it can also create a explosion and eruption within the area that have lots of water source. So if you watch in the movies, such as if you want to learn more about volcanoes and to see in action how it work, there are lots of good Hollywood movies, like the movies called I believe it's Volcano. That's the name of the movie. It's played by I forgot his name. What is his name again? Tommy Lee Jones. So that's number one. And the other one is the Dante's Peak, played by Pierce Brosnan, the old James Bond actor. And the other one is the woman who played Sarah Connor in Terminator. I forgot her name. Her name is Linda Hamilton. Okay, so if you want to learn or to see more in action with a little bit of fun, check these two movies out. So that's a good way to study about the volcano. Now let's moving on. So next is the very hard to pronounce, the astrophism process. So the astrophysics process is slow tectonics process from moving magma in the asthenosphere plates or the mantle layer, causing earth crust to move and hitting, pushing and depart from each other. So here, the lithosphere movement, lithosphere thickness away from the axis. In this case, we call them the divergent boundaries or the divergent plate movement. Second one is the process of the consuming a plate is called the subduction. This area on the middle picture, this is called the subduction zone. So this is the convergent boundaries or convergent moving plates or plates motion. So basically, the number one is the two continents, this one and this one, are moving away from each other because of the pressure built underneath the surface, where these magma are able to find the cracks and the holes and least strong, least uniform area to push out. So it creates the mid-ocean range under the ocean floor. So this is when the two continents are moving away from each other due to the pressures pushing it out. Second is the pressure is pushing the continent to move, and then it collide on each other. So the two plates move toward each other, and the downgoing plates sink beneath and the overriding plates go on the top of it, as you can see in the picture. And the third one is the transform boundaries or the transform plate motions. So this is no new plates will form and no old plates is consumed. It's just moving away from each other, and mostly are in the same elevation. No elevation change, so two plates slide past each other on a vertical fault surface, as be seen in the picture. And here is what it's able to form. These are the types of rocks that you can see in the nature, especially in the mountain. Those will form by the pressure underneath the earth. So these, as you can see here, there are different types of layers of rocks that form. It bends into different shapes, such as the symmetrical fold, the asymmetrical folds, isoclinical folds, overturned folds, recumbent folds, and chevron folds. So these, the reason and the way that the rocks look like this, because as you can see here in the picture, over here are the mantle, the magma underneath the earth pushing upward with its pressure, causing the lands to change its form into different shapes. Depends on the reactions of the magma is doing to the layer in that area. So some place it goes slope down because over here it's more strength, and on the side of it it's has less uniform, so the magma is pushing up more, causing it to bend like that. Okay, next, now this is what's so called the fault. In Thai we call รอยเลื่อน so the fault also a result of the change, the tectonic process, which we can identify them as the normal fault, the reverse fault, the thrust fault, and the right lateral strike slip fault. So as you can see here, on the normal fault, basically there are one fault that is moving from each other. One is slightly increase in elevation, some is slightly decrease in elevation, and these cause the expanding of the crust. So when the, like I said again, mostly if this happen under the ocean floor, so when the two plates are moving out from each other, right, the magma will fill in the gap, which means it's like work as a cement. So when you put the cement, or basically like the glue that are getting dry, the magma when it's come out, it hit the cold temperature, of the ocean. So in the very depth has the great cold temperature. So this hot magma comes out and hit with cold water. It basically cool down and become another parts of rocks. So this is like you taking it apart and then you fill it with magma. It becomes an expansion of the tectonic plates. Okay, and again there are reverse fault. So this pushing down and going up, this fault called the reverse fault. Instead of going this way, it's go this way, pushing on each other, compressing underneath, not pulling away. And the thrust fault is pushing really hard, really slow. So these collide and lift a little bit, but these push underneath very, very significantly. And the last one, again, like I mentioned earlier, it's just moving away in the same manner, not really create much damage, just moving along. And these types of fault can be seen like in the San Andreas fault. Okay, now exogenetic process. So exogenetic process is the tectonic process from factors above surface of the earth causing change in terrain such elevating or degrading of land. Next is important factors are surface water, groundwater, wind, ocean wave, and iceberg. So exogenetic process can be divided into 3 processes. So number 1 is weathering process, the mass wasting process, and the erosion, transportation, and deposit process. Weathering process. Weathering is the decaying process of rocks by weather with important factors such as temperature, humidity playing an important roles together. So weathering process can be divided into 3 categories. Number 1 is physical process. It means the decaying of rocks from expanding and shrinking done by the changing of temperature and humidity, causing its surface to crack. So if you see the earth that cracks into a smaller, thin layer of some rocks from the bigger one, that were happened by the physical process. So sometimes during the day it get hot, and then go at night it get colder, or sometimes there are other elements that causing the increase and decrease of temperature in a short periods of time, causing these expanding and shrinking process are not in the time that it can done by not causing damage to the structure of the rocks, such as the rocks on the mountains during the day are so hot, very, very hot, and it's expanding, and suddenly the rains drop. So when the rain drops, it cools down the rock's temperature rapidly, causing it to shrink really rapidly and crack the surface because it's unable to adjust the temperature in time. Next is the chemical process. These chemical processes are the decaying of rocks by disintegrations of rocks element by chemical reaction from acid and alkaline. So as you can see on the picture on the right, those are the stone dripping in the cave. So these are done by causing of the acid and alkali to deform, disintegrated the chemical within the rocks, and then causing it to drop down and it change forms and formations. Next is biological process, or the process that causes the decaying of rocks by animals and plants, also including humans. Biological process working together with the chemical and physical process. For example, what are the biological process? Just imagine about the plants, the trees, when it grows. It also grows its roots with underneath the ground, right? So if you plant the trees near the rocks, and then these roots were able to pushing away into the rocks. If you never know that the trees are very good in going through other elements such as rocks and buildings, so these roots can basically go through the rocks, causing it to break and crack and disintegrate or decay. So these are the biological process. Next is mass wasting. Mass wasting is a process that rocks and soil moving by Earth's gravity toward lower elevation water and quakes stimulate its motion. So as you can see in this picture, this is some form of mass wasting. Okay, so it's the changing process of rocks and soil on the Earth toward the gravity pull. Okay, and there are the mass wasting such as landslide, which is very scary, the slumped rock slide, also another scary, earth flow, very natural, and solidification process. So let's see now. So in the mass wasting, as can be seen in this full picture, it's just the collectives of the mass wasting that occur in the Earth's surface. So the number one on the left side, as you can see, that is the rock slide. So rock slide can be dangerous if it falls into the areas such as road, town, and residential area. For in this case, this is an accident. The car was traveling on the road and the rock slide down onto the roads. So the car hits the rock that fall onto the ground, causing damage to the property and injuries to the driver. So rock slide, it's dangerous, but if the structure of the area that rocks are on are maintained properly and not that area does not affect by rain or storms, it's not likely to occur in those areas. So second picture, it's called the solifluction, which is the shifting of the soil slowly toward lower elevation, and this caused mostly in the cold climates, the freezing climates, that the ice and snow will melt during the summer, and then these water that will melt from the ice and snow were going into the soil, and then when the soil was holding water but the underneath layer of the soil are still frozen, these top layers are moving a little bit. As you can see, it looks like a wave, but it's not in the water, but it's on the land. So the third one is the earth flow. So the earth flow is the soil or the decaying rocks that moving especially on the cliff side or on the high side, but it's moving toward the Earth's gravity slowly. And the last one is the landslide. This is the most scary and significant of the mass wasting. Even though rock slide look scary, but landslide is causing even more damage because it can occur in the areas such as mountain or the lands with a high elevation, and especially in the areas of raining areas that have lots of rains. Okay, so landslide again is happen with the same, and these were pulled by gravity. Okay, in the earth it has gravity, it will also pull toward the earth, which means in the high elevation will come down to the lower elevation, basically come back to the ground. So these soil as the top layers of the land, right? When the rains come, the soil will absorb water, holding water in, increasing its weight. So when the structure of its original land are not able to carry or hold on that increased weight, this soil, the absorbing water will let go and slide down. and it usually happens in a very big area, and the damage are so significant it can wipe out the house, the buildings. People will be dying due to suffocation and impact of these massive weights of lands. So if it happened in the residential area like in the picture, it will be very scary because it was unlikely to survive from landslide, because if it does drop, you will have no time to escape. You have to protect yourself from impact, and even the building can hold in place of the impact. So what will happen if it hits you? If you're lucky enough, you maybe survive, but it always comes with lots of damage. So landslides are very scary. And if you remember back in the days, teachers always say, oh, you should plant lots of trees. Trees will help and stop the landslide. And do you wonder why the teacher always saying that? There are the reasons behind all this idea. So if you remember, we talked about the plants earlier, about the trees in the biological ways that the trees can degrade the rocks, that the tree have its roots growing through underneath the rocks. And that is the idea, because the trees have roots, and roots holding tree in place, but also act as a structure to hold the land and soil in place as well. So think about when they're doing the construction, they are creating the cement floor. Before they pour in this cement, they will put a steel, the tubes of steel in a table manners, like many tables, right? Not the table we use, like the table, you know what I mean. Okay, so these steel will act as a structure to hold the cement in place. So when the cement, when it's dry, it will be holding on to these tubes of steel. To compare with the cement floor with no tube of steel, if it cracks, it usually cracks and pulls away and creates lots of holes and breaking, because there's nothing holding them in place. When the structure rigidity has been decreased, it will fall. But compared to the one with the tube steel, the cement floor holding in place much better, because the rigidity, even though in the cement is losing, but there still be the steel tube structure holding, same as the tree. So the trees, the place that have lots of trees in the mountain are not likely to have the landslide happen in that area, because the tree roots hold the lands in place. Okay, let's moving on. Next is erosion. So erosion is the surface leveling process by nature. Important factors are surface water, again, groundwater, wind, ocean waves, and iceberg. So these factors eroding the surface into sediment. So the eroding factors then, when it erodes into sediment, it transporting this sediment until it deposits into the new terrains. And these new terrains can happen both above and underwater. So erosion process consists of, number one, the erosions, which mean the scouring, the scratching, collidings, and wind blowings of the rocks and soil, basically. So the scorching is like the scouring is like when the water is hitting into the shore, it pushing into the shore every day slowly until the shore, it's either be rocks or lands, start to decaying and disintegrated. Those are the scouring. And scratching is when these rocks that were in water, or it will fall into the water, and the water is moving it's with the current, and it's scratching, hitting other things until it's slowly breaking and cracking to become smaller rocks and later become the sediment, or colliding, such as the water pushing the rocks along with its current, and then suddenly it hit, traveling with the water speed, or an impact or collide with other objects or other rocks, breaking or cracking into smaller pieces. And the wind blowing, erosion can occur by wind as well. So when the wind blows, time by time, the winds also carry the airborne particles, and these small particles are used to be rocks and sand before. It's in very small diameters, but still effectively it's like a invincible sandpaper. So if you ever use sandpaper have the friction and it's scratching to basically cutting into the elements, and these elements that were cutting it were disintegrated into small particles like dust. Okay, so those are the wind blowing. And transportation, the suspension, the wash away, creeping or rolling. So the suspension is like the water carry this sediment into its currents. So the sediment is small, sometimes it's even small like the particle dust in the wind or in air, but now it's in the water. Like when you see the water looks dark. Those are because of it suspending this sediment with them. Okay, so if you see the dark water, better clean it and purify it first, filter it first, so you can see that they contain lots of sediments and particles. And wash away is like those rocks that were washed away by water or dragging it along in its currents. So that's how these can travel, how they can transport these to another way. Creeping and rolling also can done by wind. When the wind blows rocks are moving little by little, rolling by little, creeping by little. And when these sediments, these rocks, this whatever, it's moving in the transportation process, after it being eroded, it will decompose. It will be deposit in the new area. So the alluvial is like the mud that carried by the water. The water puts this mud and form another area. Or the Olean deposit, which is caused by the wind blowing dust and forming into a new terrain, or even marine deposit. So marine deposit is like the particles, the sediments that were carried out by the sea, by the water, by the ocean, and it formed maybe a new island underneath the water surface with the high ocean floor, or even forming causing the, if you see in the picture, now you can see on the biggest picture, this is done by wind. So the shapes of these rocks and mountains were done by winds, carrying on the small particles and scratching it little by little, day by days, and it formed into this kind of different shapes, different types of shapes. And on the top right picture, this is the deposit of the sediment done by both the oceans that can either taking down this area right here. So this is the land, right? When the oceans come, hit this land and dragging it down. So you can see this light color underneath the seas and ocean. Those are the deposits of this sediment done by the ocean or the water when it rains and dragging down the eroded sediment into the ocean, forming a new area underneath the water. So like I said again, the sediment does not need to be on surface. It can be under the water surface as well. And the last picture on the top, this is basically showing that the erosion process of the water scouring the shore. So the water is moving in, hitting little by little, dragging away all the eroded rocks and soil into the water, causing the lands to collapse. So very, very scary. So these changing can cause the land to decrease in terms of size and area, and it will later resulting it will affecting the ways people live. It can reduce the residential area or roads or so on and so forth. Moving on. Now let's talk about the atmosphere. Only one sphere we have come down to almost 50 minutes. So let's not waste our time. So atmospheric composition. This is the gas, the elements, the compositions of our atmosphere. So 78% of our atmosphere within the air we live in, this is the nitrogen, the 70% part. And then oxygen is only 20.9%. And then there are other gases such as the argon gas, listed at 0.9%, carbon dioxide at 0.03%, and other gases like water vapors and stuff at the 0.17%. So if you talk about the Earth, the major components of the air we breathe are oxygen. You are wrong. It's basically nitrogen. Now, let's take a look at the layers of Earth's atmosphere. So, Earth's atmosphere can be divided into 5 spheres. So, the top and the outer sphere, the highest layer are the exosphere. Then it's thermosphere, mesosphere, stratosphere, and troposphere. So, the sphere that are basically in the sphere we're living in are the troposphere. In this layer, the temperature can be varies from 15 to minus 56.5 degrees in troposphere, but if we talk about the land surface of sphere, it can be greater than 15. Okay, so the troposphere can vary from the 0 kilometers up into 12 kilometers, which is have the very high climate change, because of sometimes they have winds, they have rain, they have storms. The weather is quite violent in this troposphere, which is the layer we are living in. That's why we see rain, we see storm, so on and so forth. But if you go upper in the stratosphere, this is starting with this is the sphere that have the ozone layer that protecting the radiation of the sun that are coming to the Earth atmosphere. Okay, and stratosphere have quite calm weather rather than the troposphere, and the temperature is very around minus 56.5 degrees Celsius to minus 2.5 degrees Celsius. So you can survive up here, you will be frozen to death. And then go upper. The stratosphere is around 12 kilometers to 50 kilometers in elevation. And then from 50 kilometers to 90 kilometers are mesosphere. These areas are temperature is around minus 2.5 to minus 86.5 degrees Celsius. So as you can see, the temperature varies. The higher it goes, the temperature will be lower. However, it also can increase due to the components and elements of that layer, such as the thermosphere. The temperature can be vary from 86.5 to 1200 degrees Celsius. Same as the exosphere, 1200 degrees Celsius. That's the result why the space shuttle, when it goes up in space and come back onto the Earth, it requires a very heat-resistant component to build this spaceship. If you don't have this heat resistant, it will burn before it reaches the ground. So very scary. And to understand in the picture on the right side, in the troposphere is the layer where we travel, such as the passenger plane are flying, the air balloons. This area, if it's not too high, the temperature is still okay for humans to survive, and the air pressure and the amount of air will still be breathable. But the higher it goes, the lower the pressure, the less density of air, meaning we are going to die from suffocation because the air is more density on the ground. Next is stratospheres. They use this part of the layers of the atmosphere. Sometimes there are planes flying here to avoid the weather. Like if you see many movies, sometime when you are in the airplane, the pilot will say we have to increase our elevation in order to avoid the clouds, the lightning storms, the bad weathers that are happening in a troposphere. However, it does not go too high, just only at the boundaries between the troposphere and stratosphere. And for the mesosphere, this area, those meteors and meteorological rockets are burning, disintegrating in this part of atmosphere. And for the thermosphere, you can see the aurora happening. Those are happening in the thermosphere due to its electromagnetic field that were in there causing varies of temperature such as heat. And exosphere is the layer, the most outer layer of the Earth before we enter into deep space. This area is where the spaceships are flying above, as well as the satellite are orbiting the Earth's space. Okay, let's moving on. Now we'll talk about the solar energy. Again, solar energy, it's reducing many electromagnetic radiations, okay, such as ultraviolet, electricity, infrared, so on and so forth. And this energy, this radiation, when it comes from the sun 100%, it will be absorbed and reflected by the atmosphere, by clouds and lands. So when they hit the surface of the Earth, the percentage of the energy absorbed and reflects varies, depends on the shapes, the elements, and the composition of the surface, such as the water and land are different in terms of absorption and reflecting heat. So have you ever wondered when you in the morning you go swimming in the sea or in the swimming pool or the water sources, the water tend to be cold during the morning, even though the sun will rising and the outer part on the land are quite starting to get hot, but the water is still cold. But when at night, when the suns go down, everything's nice and cold, but the water is still warm, or some part is a little bit hot. That's because of the different elements of the water and the soil. The soil being a solid, it's absorbing more energies, but also can release it much faster, unlike the water that holds the heat longer than the solid part of the land. Okay. Now, let's talk about the atmospheric temperature. The atmospheric temperature is the heat level that atmosphere that Earth absorb in the atmosphere that Earth absorb from solar energy, and varies by these following factors such as the location and latitude, which mean the area you are living on Earth also causing the change of elevation the change of temperature, and this is measuring by the latitude in terms of location, because remember, if we talk about the Earth as a sphere, so spheres is a circle shape, 3D dimensions of circle. It will have its high point and its low point. So the high points are in the area of what we call the equator, and this equator, the highest point, that since the Earth is tilting around 23.5 degrees, making the equators receiving the solar energies all year round. And for being so, these areas at the equator tend to have the higher temperature than the other parts of the Earth, causing it to have warmer and hotter climates. Okay, but if you go to the other part of the Earth, go up or go down, further away from the equators, maybe go almost near the North Pole and the South Pole, you can see all these poles, which is not much of absorbing solar energy like the part of the equators. The North and South Pole are having a very freezing climates because it's not receiving as much as solar energy to create heat in the area. And second is elevation. So the higher you go, the colder it gets. If you remember the Thai phrase, people always say ยิ่งสูงยิ่งหนาว so that's because of in high elevations they are they are far from the ground, and the ground on the surface is causing them to absorb more solar energy. The higher it gets, also the lower air pressure, the less density of air is not holding heat as much, because heat will reflect and go back into the space. Okay, so that's why the higher it gets, the colder it will. Okay, next is types of the surface. Like I said earlier, between the water and the ground have different capability in absorb and reflecting heat, causing them to have varies in temperature. Okay, next is season. Again, the Earth's not only orbiting around itself but also orbiting around the sun. So the location of the Earth sometimes is further away from the sun, closer to the sun, causing the solar energy receiving to be differ and causing different kind of seasons, and these different kind of seasons also cause the temperature change. For example, in one season it used to be hot and humid, and next season it's start to be cold and snowing. So those are the difference in terms of season that affecting the temperature of the Earth, even though we are not moving anywhere, but that area can change. Next is the daily temperature. Sometimes the temperature due to the storms, the formations of the wind that blows in, and the human activities, the water source that can be vibrates into the air and forming and becoming rains again, can also affecting the daily temperature. The day that have rains tend to have lower temperature because the water is cooling down the temperature in the area. Or even in the snow season, one day there are no snow, they are sunny, so the outside temperature is not as cold as when it was snowing, so the daily temperature also change and affecting how the temperature of that area is. Now let's talk about the atmospheric pressure. Remember, when we talk about the atmospheric pressure, that the higher you go, the colder it gets. It's because the higher it goes, the pressure it will be reduced, because the air is also like the other masses, it has mass, it has weight, right? So the density of the air, meaning the air on the top pushing down toward the gravities of the Earth, causing the density to be more, making the air much more heavy into the lower altitude. And this lower altitude with low with high pressure. The lower you have high pressure will make the high pressure tend to have colder temperature. The lower pressure tend to have higher temperature, and this is done because if you remember, when you're boiling the water and the water evaporates, right, this high heat go up because it's lighter. It's not as, because the air expanding, when it expanding, causing the density to be reduced. So when the density reduced, the hot weather, the hot air and the cold air, hot air is lighter than the cold air because the cold air has more density. It will be heavy. It will circle in the lower altitude, and the hot airs go above. And this atmospheric pressure causing the weathering in the world, in the Earth's surface, such as the wind. So the Earth's wind system, as you can see here, they are circles, goes around, right? So just to be understand that in the equators area are the hottest part of the Earth due to the solar energy it absorbs as the angle are pointing and in conjunction with the sun. Okay, and these have hot airs, and the hot airs will go up in terms of altitude and elevations. When the hot air goes up, the cold air come and replace its place. So when the hot airs go up, it's getting cooled down, and then it moves toward the polar, either it's a south pole or the north pole. And then when it gets cold enough, it will traverse back toward the equators. So hot air goes to the polar and cold air to go to the equators, okay, causing the wind system. And also the winds not only go in that direction, it also shifting west and shifting east. We call the westerlies and the easterly winds, and also the northeast trade winds and southeast trade winds. And these shifting on the right and left side are done by what's so called the Coriolis effect, which is done by the rotation of the Earth. For example, if you put a balls on the circle surface and you spinning it, if you spin the clockwise, the ball will shift to the left side due to the gravitation pulls. And if you spin to the counterclockwise or the opposite of the clock, the balls will shift toward the right due to the gravitation pulls. Okay, so that is the Coriolis effect, causing the wind in the Earth's surface to moving left and right. Okay, not only go up and down, but it go left and right. Okay, now the air mass. Again, air mass can have a front that it hit from the warm air and the cold air. So this, when the warm air lifts, the cold air comes down. Okay, and these areas have two different ways. They are the cold air front and the warm air front. So this is the cold air front, which is the cold air is moving toward the warm air, causing it to rain heavily but not widely. In the other scenario is the warm air is pushing forward the cold air, pushing it down, causing it to widely rain in the area of the confrontation between the warm and cold air. Okay, move on. Now the humidity and cloud. So the humidity and cloud you can classify by the elevations of the clouds. So there are three different elevations we call the high, the middle, and low. So the clouds are on the high is the cirrostratus, the cirrus, the cirrocumulus cloud, and the other one is the cumulonimbus. Can be vary from low, middle, and high. It's gigantic in size of cloud. And in the middle area is a nimbostratus, the altostratus, the altocumulus, and on the lower altitude we have the stratus, stratocumulus, the cumulus, and also the cumulonimbus. Very hard to pronounce name. Okay, so in these levels of cloud showing different types of humidity. So the higher it gets mean the lower densities. Sometimes those clouds you can see it's not highly in humidity and it's not heavy. The formation of the cloud are not likely to rain. But the lower and the middle and the lower, if the clouds are formed and very big, these are holding lots of water in terms of evaporations, and it can fall down into heavy rains. Okay, moving on is the precipitation, forms of water such as rain, snow, sleet, and hail that fall to the Earth's surface. So the rains, that is part of precipitation, the evaporations, the clouds form together and get so heavy, and when the hot and cold air hit each other, then the rain falls into the water drops. This is rain. And the next one is in the cold temperature, very cold, the water freezing and drops down into the snow in very beautiful small snow. The other is the sleet. Sleet is the rain, but it drops in the cold climate. And when it drops, the water drops down into ice in terms of the water drops, but in an ice, not a liquid like rains. Hail is like a sleet, but slightly it's more than sleet. Sleet is the water, the raining in the cold climate, but hail is the freezing cloud, that fall down onto the surface. Mostly the hail are measured at 5 millimeters in diameters, which is bigger than sleet and cause high damage. If you get hit by the hail, you can injure yourself or die if the hail are very big. Next is hydrosphere. So talk about hydrosphere. The water on Earth, lake and rivers are at 0.3%. Groundwaters, soil moisture, swamp water, and permafrost at 30.8%. Glacier and permanent snow cover are 68.9%. Is that correct? Wait a minute, isn't the ocean some more? You are perfectly correct, but these numbers that showing the percentage of the fresh water. So the world, the total water at 97.5% are salt water or the saline water, and the fresh water are only 2.5% in the earth. And again, the numbers of 0.3, 30.8, and 68.9 are the part of these 2.5% only. So you can see that water on Earth, usable water, drinkable water, are significantly low in terms of percentage. But if you build a really good water filtration and purification, water purifying, you can, like the country in Australia, they don't have much of water source, so they fix this situation by purifying the salt water. So that is another smart way to go. So hydrologic cycle or water cycle. Basically, the waters gets what? Waters on the surface gets heated up and evaporates. So when it evaporates into vapors, go up into the atmosphere, and then when it get condensation too much, it's precipitated and then fall down into the rains. So the waters can come from the groundwaters that leak into the water source, or the plant taking up the water source into its roots and transpirate the water in terms of evaporations, and then it condenses up into the cloud and then it falls down. Or the waters from the lake, the river, the stream, or the water source on the other part of the ground can also evaporate and then start to get the condensation and fall down. So these are the basic hydrologic cycle. Water gets evaporates and it condenses and then it falls down back on earth. That's the water cycle. Okay, hopefully you all remember this have been studied since primary school. Now, fresh water on the earth's surface can be found in this following, such as surface water like river, stream, swamp, lake, snow and ice on the mountain, and water, vapor, or cloud. So the cloud you see, those are the fresh water. But in today's, you can't really call it fresh water anymore because the clouds are contaminated with many particles and chemicals such as the acid, the sulfate because of the air pollutions. Okay, so do not drink directly from the cloud. When it rains, you have to purify it first. Next is the groundwater system. The groundwater system, as you can see here, these rocks, the tiny rocks, are called the aquifer, which is the layers of rocks that holding in water. It's the small rocks pushing each other, and in between there are tiny space left, and that space is where the water resided in. And in the groundwaters, you can use it by drilling the hole until you hit the layers of the aquifers, and then it will pop out automatically because they have higher pressure underneath, such as the spring or the well when we man created well, or the basically nature created well. And these water, this aquifer, all usually have the other layers of rocks that not allow the water to escape. So the water only goes up above ground from man-made holes or the crack in the surface, okay, which means we have lots of water, fresh water underground than we see. But this is not recommended because if we do taking water from underground source, it will cause the collapse of the land, because when the water were taking out underneath, it start to have empty space between rocks, and this empty space causing losing the rigidity of the structure of the ground and causing it to collapse. So very scary. So do not use groundwater if it's not necessary. The saline water system. The saline water system on Earth is the water in the ocean and sea. So the water out from the salt mineral on the land that transport to ocean and sea. Its compound are chloride at 54.3%, sodium at 30.2%, sulfate at 7.6%, magnesium at 3.7%, calcium 1.2%, potassium 1.1%, and others substances are at 1.9%. So the 1 liter of the saline water usually contains 35 grams of salt compound. And the ocean and sea currents is caused by the temperature, salt level, wind, and Earth's rotation. So we can differentiate by the upper or the surface current will be affected by the wind of the Earth, okay, and the temperature change. But underneath, it go more to the salt level, the Earth's rotation, the gravity pulse, and so on and so forth, okay, and also the temperature within deeper, the cold current and the warm current, also resulting in the shifting of currents. Okay, now the last one, the biosphere. The biosphere is basically the study of living things on Earth, and when we talk about the living things, the environment of that area will resulting in the development of the living things, such as the plants, animals, and humans. Okay, so human basically we try to adapt into the environment. Okay, so the climates are the main factors that causing in different developments of plants and animal living in the area. But human, we are still the same human. We can live everywhere if we are able to adapt. So the difference of human in each area, in each climate, are by their culture, the way they adapt, the way they live, because we have to live according suitable for the climate. But the plants, it will be different in the species, because some plants can survive in cold, some plants can survive in the hot areas such as desert, and some animal again, its species will adapt it to living suitable to the area. Okay, so that's why only plants and animals are adapting in terms of genetic to be able to live with different environments. But human, we adapt in terms of our culture, our surviving skill, but not in terms of genetic, only the ideas and adaptations of methods, how do we live in each day. So we have here, this is the biome. Okay, if you can see the chart, they are divided into different types of the climates of the earth, such as the tropical, the temperate, the subarctic, and the arctic. So the down at the tropical, we have the rainforest, we have the savanna, we have the desert. And this area, rainforests have lots of trees, especially the trees that are very big and strong. Many animal and wildlife are living in the rainforest because it's able to generate many foods and be the homes of the animals, both mammals and reptiles, birds, so on and so forth. And savanna is also for another types of climates that allow many plants such as shrubs and weeds and many types of grass, or some big trees are allowed to survive in the savanna. And in the savanna climates, you can see many animals like in Africa. And desert, of course, not much of the plants are allowed to be able to survive in the desert areas, such as only for some plants like cactus, some animals like oh, there are lots of animals that are able to survive in the desert, like a sand cat, like a camel, like various snake types, various insects like scorpion, spiders, so on and so forth. Okay, so basically biome is showing different types of climates of environment affecting in the growth and development in terms of genetics and behavior of the plants, animals, and humans. And now that's it for today. It's time for Q&A. Any questions, feel free to ask. Any suggestion, feel free to tell me. And the further I speak, the voice and everything is changing. My mouth is dry because I speak for over an hour and it's really hard to speak, so sorry about that. And if you have any confusions, please, I really want to see you asking me, other than how do I turn in the homework and do I have to do this and so on and stuff. I want to see you showing your opinion, showing what you feel, what you think about the stuff we learn. Especially today we learned about the earth physical change, okay, the earth physical components. What do you feel, what do you learn about this? Feel free to share your ideas. I would like to hear and I would like to discuss with you if that's possible. Okay, and I will not take much of your time anymore. Please don't forget, if there is a homework, I will post it in Google Classroom. If there is not, meaning there's no homework. Okay, and don't forget to turn in the homework from last week, and I will see you again very soon. Thank you for coming, class, and have a wonderful day. Goodbye.